We have mentioned computer systems, and we talked about computer system hardware and software. Inside software, we have computer program. And we also mentioned a program is a set of instructions a computer follows in order to perform a task. In order to write a computer program, you need to use a certain programming language. A programming language is a special language used to create computer programs. Computer program is a set of instructions that enable the computer to solve the problem. Collectively, these instructions form an algorithm. Algorithm, to put it in simple, is how to resolve a certain issue in a mathematical way. An algorithm is a set of well-defined steps to completing a task. The steps in the algorithm are performed sequentially. So this is called deterministic. You know where it will go when you write the program. It's not run randomly. A computer needs the algorithm to be written in machine language because machine language is the only language that the computer knows. It's written using binary numbers, 0 and 1. The binary numbers are encoded as a machine language. Each CPU has its own machine language. Intel x86 series processors may have different machine language versus Motorola 68000 series. Example of a machine language instruction is like here, 1011 something, a series of zeros and ones. And the exactly meaning depends on the CPU it runs. In the distant past, programmers write programs in machine languages. Actually, it's not so distant. I believe my first job was to write machine language programming for industry processors. So programmers develop high-level programming languages to make things easier. The first of these was assembler. Assembler made things easier, but was also processor dependent. It directly translates machine code into certain kind of mnemonics. For example, this 1011 may be translated into move. This 0100 may be translated to certain machine address. So it's easier for human beings to read, but it's still machine dependent because 1011 may change its meaning if you move to a different processor. For this reason, there were something called high-level programming languages. These high-level programming languages are not processor dependent. Some common programming languages, including C or Python or Visual Basic, and including what we are going to learn in this course, Java. There are some concepts that are common to virtually all programming languages. All programming languages have something called keywords and operators. And they make use of punctuations. They also encourage programmers to define their own identifiers, and they will also have strict syntactic rules. Here is a sample program of Java. This is the public class, hello world. Here, public, class, void, all these are keywords that is reserved for Java programming language. You cannot create something on your own using this keyword. You cannot define something called class or static. These are reserved for Java only. There's also punctuations like this curly brace or this semicolon that's used for Java programming language to properly organize different statements And finally, there are something that you can define on your own. This is programmers created identifier, like hello world. Keywords in the sample programs are public, static, class, void. Right? They are all in this particular Java language. Keywords are all lowercase. Now note that Java is a case-sensitive language. Some languages not case-sensitive, such as Visual Basic, but Java is. So lowercase class and uppercase class are two different definitions. And remember, keywords cannot be used as a programmer-defined identifier. It's reserved by program Java, and you cannot use it. You cannot use it for your own definition. You have to use it the Java way. As for punctuations, we already see that we use semicolons are used to end the Java statement. However, not all lines of a Java program end in the statement. Part of the learning curve is to learn where to properly use the punctuation, including semicolons and curly braces and the square bracket. There are differences between lines and statements when discussing source code. For example, here, system output out print line message. This is one Java statement, but it's written using two lines. You can also put message here to form a one line. You can also put this message and closing parenthesis and the semicolon up in the first line, making it one line. It's still one Java statement. A statement is a complete Java instruction that causes the computer to perform an action. It ends with a semicolon. Here, there's no semicolon, so it's just a part. This line is just a part of the statement. Data in your Java program, as we discussed, is stored in memory when you run the program. They are stored in a certain location, and these locations are represented by something called variables. Each variable name represents a specific location in memory. They're sometimes called fields because it's where the information are stored. Variables are created by the programs who assigned it a programmer-defined identifier. For example, here we defined an integer hours equals to 40. This value 40 is stored somewhere in memory, and that location has an address. In this example, the variable hours is created as an integer and assigned the value of 40, which means 40 is somewhere in the memory, and hours is pointing to this address. Variables are simply a name given to represent a place in memory, so that we can see here, we have an integer length equal to 72, right? 72 is stored in a byte in memory, and this place has an address of 003. When the Java program sees this length, it knows this length is pointing to this 003 address. The variable name length is a symbolic name for the memory location 003. The Java virtual machine, which in fact runs the Java program, decides where the value will be placed in memory and assign the address to the variable name.